Hello and welcome to Nikolay's biostatistics lessons, and today we are going to talk about how to find the score, its significance. We are going to solve simple problem, and then we are going to analyze what this data tell us. Now I want you to pay attention to this graph with standard distribution of data, and imagine that we have a certain measurements, let's say here, which I show with red dot, to which we want to assign the score. We may have many such values, and we can assign the score to each such individual value. So what is the definition of the z-score? It is known as standard score. It is a statistical measurement that describes the values relationship to the mean of the group of values measured in terms of standard deviations from the mean. In other words, we just assign a value, z-score, to each such individual value in order to tell how far and in which direction from the mean of the population such value is. Z-score, it is dimensionless quantity that represents how many standard deviations an element is from the mean of the population. Of course, we can compare different values in absolute numbers within the same research. But if we compare different scientific papers, we would be more interested in relative numbers, such as how many standard deviations from the mean certain value is. So we assign the score to such values. Now let's solve our problem. Suppose you are a researcher studying the systolic blood pressure levels of adults in particular population. From previous studies, you know that the systolic blood pressure levels in this population are normally distributed. The mean systolic blood pressure is 120 millimeters and standard deviation is 15 millimeters. You are interested in assessing how an individual with systolic blood pressure of 135 millimeters compares to the rest of the population. Find the score. We are going to use following formula. So z is equal to x minus mu divided by standard deviation, where x is our value, mu is a mean of the population, and standard deviation is a measurement which we also given in our problem. For example, within one standard deviation from the mean, we can find 68.26% of all data collected, and within two standard deviations from the mean, we can find 95.44% of all data collected. Now let's put numbers. So z would equal to x, which is individual measurements, so individual with blood pressure of 135 millimeters, so 135 millimeters minus mu, which stands for the mean of the population, and we know that it is 120 millimeters, so minus 120, and divided by standard deviation, which we know that it is 15 millimeters, so divided by 50. So this is going to be 15 divided by 15, which equal to 1. So z here equal to 1, or to 1 standard deviation. And because this is positive number, that means that we have to find this point somewhere here. So this value is going to be above mean of the population and within exactly one standard deviation from the mean. So z-score of this point is going to be 1. Now, how do we interpreting this z-score in this biostatistical context? The score of 1 indicates that the individual's systolic blood pressure is higher than the average of the population. Next, The positive z-score suggests that the individual's blood pressure is above the population mean. And while this individual's blood pressure is higher than the average, it is only one standard deviation above the mean, which is typically considered within the range of the normal variation in a population. However, it is important to note that the medical interpretation of blood pressure values also considers other factors such as age, overall health, and medical history. And this is all for today. Subscribe and see you in the next video. Goodbye.